These are all the subatomic particle, and the scientific community is still advancing and simply finding out the new particles. Okay, for example, neutrino, boson. These are also the subatomic particles. Okay, and many news regarding there is a project in Tamil Nadu, Indian Neutrino Observatory project. Okay, so that is being constructed in Theni district of Tamil Nadu. Okay, so they are trying to study about the neutrinos. Okay, so not the neutrons, it's a neutrino project. Okay, so everything will be knowing in our science classes. Okay, so first of all, see, they come to know the protons. Remember, I tell you one example. So based on that, you can come to know. Okay. So there is a bag. Okay, consider somebody is holding the bag. Okay, in a very distance, very remote, and you are able to visualize them. A person is holding a bag. Okay, and the bag is something large, looks like large, and you just think it is. I mean, the bag is filled with tomato. Okay, the bag is filled with tomato and onion and potato. Consider the bag with this stuff. Okay, you are visualizing the bag from the distance. Okay, enough distance to visualize. Okay, then after, as you are reaching, you want to know something about the bag, so that you are approaching the bag. You are just stepping ahead towards the bag, and you are just on seeing it, you are predicting, you are assuming something that it is the bag, but you do not open the bag. You are not opening the bag, but assume that the tomato will be, onion will be, potato will be inside the bag. Okay, and now you have the knife in your hand. Okay, so you are just asking the person and to give the bag, just this for example. Okay, so and you are just simply making an incision. Initially you thought that the bag is cannot be, make an incision upon the bag. You don't think that the bag can be teared or can be teared. You don't think initially, but now you are having the knife. Okay, now you are making an incision on the bag. So where you are finding the tomato and the onion, potato. Initially you find only the tomato. Then you are having some stick with your hand, and with the stick you are just simply kindling, and on kindling you find the onion, and again you are kindling, again you find the potato. Okay, so now you come to conclusion that these are three stuff is in the bag. Okay, but after some time you are having some lenses in your hand. Okay, you are having some zooming lens. Then you now only the zooming lens arrived at you, and you started looking at the bag into the bag, and you are finding just some mustards are present in the bag. Mustards. Okay, and again you are looking in the bag, and some other small stuff lesser than the size of the mustard is present in the bag. Okay, this is the same way the subatomic particles being found. Okay, consider these are the tomato, onion, and potato were example for the subatomic particle. Okay, for example, as I told you in the story, a person is standing just at the visualizing distance, and you are looking at the bag. So that means the scientific community initially identified there is something called a small particle that is called atom. Okay, then as the science advancement happened, as you walked towards him, the science advancement, the time elapses, people found out some technology to approach the atom. Okay, initially they thought the atom is unbreakable, then they broke it. The same way what you did, you are simply made an incision upon the, you are just tearing the bag, and you found out the tomato, onion, and potato. The same way the scientific community also found out some technology. Okay, found out the subatomic particle, proton, and later electron, then neutron. These are the things they found it, because it occupies 90, almost 90% of the space, entire space of the atom is occupied by this. Okay, so initially they confined, okay, only these particles are present in the bag. Okay, so that is why some 100 years, nearly 100 years ago, people thought only these things are present in the atom. Okay, later the advancement, as you are getting the lens, right, as I told you in the story, right, so you are getting the lens, and through the lens you started looking into the bag deeper. Okay, the same way the neutrino, as the scientific technology advances, as the time lapses, due to technological advancement, the neutrino was found. Okay, then there was a prediction. Okay, the bag may contain some other particles also, some other small particle also, and that too among the particle boson, Higgs boson, called Higgs boson, otherwise called as a God's particle. You got the point? Okay, so Higgs boson and neutrino, Higgs boson, and some other particles also is predicted to be present in the inside the bag. That is, inside the bag means I am talking about the nucleus of the atom. Okay, for example, this is a nucleus. Consider a mango is a atom. The inside the seed, inside the mango fruit, there is a seed, right? So that is the nucleus. Okay, so if we consider the entire football ground as an atom, if the football is placed at the center of the ground, and that is the nucleus. Okay, atomic nucleus. Okay, so this is nucleus, this is atom. Can you imagine? Okay, as the advancement of the technology happens, we come to know about more about the scientific, more insights into the particles, more insight into the atom, and more insight into the subatomic particles. Okay, initially they thought only three things were present, but later they add on boson and neutrino and everything. So scientific community now trying to figure out what will be the usage of these subatomic particles. So that is why we are in Theni Pottipuram, in Tamil Nadu. They are trying to find out the neutrino properties of neutrino by just letting the neutrinos to pass through the instrument they are keeping, and through that we come to know about the very usage of the particular subatomic particle. You got the point? Okay, so see, protons and electron, neutron, these are all the major subatomic particle. Okay, so these major subatomic particle, how these are contributing to us, to the scientific community, and what is the very usefulness, or what is the usage, what is the benefit of knowing all these things, proton, electron, neutron means? Yes, let me enumerate it one by one. Okay, so pro means primary, pro means progress, primary. Okay, the word PR starts with PR means any word starts with the PR means it's called primary. So first, like that. So since proton was discovered first, they name it as a proton. So a subatomic particle, so that is why it is a proton. Okay, right. So now we come to know proton, electron, neutron are the subatomic particles. Okay, so now we must be knowing the structure of any atom. Okay, we must be knowing the structure of the atom. Okay, right. So atom, you can imagine like a small ball. Okay, cricket ball. Okay, so inside the ball is an empty space. Inside the ball there is air is filled with, right? So that one. Otherwise, you can call it as a grape. Grape is a very classical example for comparing the atom. Okay, so grape. Consider the grape as an atom. Inside the grape, the seed is present. So consider the seed is the nucleus. Okay, okay. So since an atom, okay, this is a nucleus. Okay, inside the nucleus, the proton are present, neutrons are present. and electrons are orbiting. So the orbit is nothing but here the orbit is. That is the skin of the, we can say it's the skin of the grape. Okay, don't think that, I mean, this is a very normal model. I mean, it's a very visual representation model. For the understanding purpose, you can take this. Okay, right. So basically, okay, these are all called orbitals, we can say. Okay, there is the nucleus is present. Around the nucleus, the electrons are orbiting. Okay. So these are all the electron orbits. It's a 2 dimension I am giving. So for 3 dimension, I give you some example and try to understand it. For example, there is a small fruit, okay, around which the house flies are flying. It is simply circumnavigating like this. For example, consider this mouse as the nucleus. Okay, the electrons are orbiting in this manner. For example, some electrons are orbiting in this way and some electrons are orbiting in this pattern. Okay, so how a housefly is simply circumnavigating any mango or any sweet, any candy. Okay, so in this way. So that is the orbiting manner of the electron with respect to nucleus. Okay, but for our purpose, for our convenience, for our study purpose, we are simply we are representing the atom in a 2 dimension like this. But this is not the true one. Okay, you can imagine. Initially, for example, have you seen the Doordarshan advertisement? Okay, the globe, and around the globe, I mean, some stars will be simply orbiting like that. The old Doordarshan advertisement. Okay, otherwise give the different example, right? So there is a candy, sweet candy, around which the house flies are orbiting. Okay, 1, 2, 3, 4, 5, 6, 7. So in this way. Okay, right. So, but for the representation purpose, study purpose, we are representing these things. I mean, atom in this way. Okay, right. So this is a nucleus, and around the nucleus, the electrons will be orbiting. Okay. Electrons will be orbiting. Right? So electrons will be orbiting here. Okay. And there is, we can say it is, we can represent this as a athlete pathway. So athlete, okay, this is the ground. So around the ground, there will be a pathway for track for the each athlete. Okay, that's it. So each athlete is considered as a electron, and the track will be the orbitals. Okay, can you make a simile? Can you compare it? And there is a very innate natural rule that each orbit can be occupied only with the particular number of electrons. Okay, that can be governed by the formula 2n square. Okay, so this is a orbital number. Consider this as a nucleus, first orbit, second orbit, third orbit, and this is a fourth orbit. Okay, 2n square. So n is representing the nth orbit. So first orbit, second orbit. So that means 2n square means we can calculate the total number of electrons can be accommodated in a single orbit. Okay, that we can arrive at using this formula. Okay, 2n square means 2 into 1 square is equal to 2. So on the first orbit, only 2 electrons can be accommodated. Okay, so this we do not know why it happened, but it happened. Okay, remember, always science explains how it works, not why it works. Remember, science is all about how it works, not why it works. We do not, I mean, the science has the limitation, but the spirituality has no limitation. Okay, if you want to know why it works, means you need to become the spiritual leader and know you need to undertake the spiritual journey. Okay, so here we are here to know the very basics of the science and how it works. So that is what the motto of our class. Okay, so don't ask, okay, why only the two who determined only the 2 electrons are present, 2 electrons can be accommodated in a particular thing? Please do not ask. I myself do not know. Okay, right, let it be. So 2n square, and the second orbit 2 into 2 square is, for example, 2 into 2, 4, 4 into 2, 8. So second orbit can accommodate 8 electrons. Okay, second orbit can hold 8 electrons. And third, 3 into 2, 2 square is equal to, for example, 2 2s are 4, 4 3s are, 1 minute. No, no. I simply translocated the formula. So 2 into 3 square. Okay. So 3 3s are 9, 9 into 2, 18. Okay. Then 2 into 4 square. So 4 4s are 16. Okay. So 4 4s are 16. 16 into 2, 32. So the fourth orbit can accommodate 32 electrons. Okay. Right. So remember how these atoms are working. Okay, it seems to be very interesting. It is very strict manner they are accommodating. I mean, the atom is accommodating. Not even a single electron can be extra on a particular orbit. If it is, even though if it is having means, it is called ion. Okay, remember the nucleus hosts the many particles. Among the major particles, only proton and neutron. So protons are held up in the nucleus, and neutrons are also present in the nucleus. Okay, so the total number of protons, how many protons present in the nucleus, that determines the very nature of the element, whether it is a hydrogen or helium or oxygen and whatever may be. The number of protons represent, and the number of protons exhibit the very nature of the element. Okay, if it is present, for example, if it is hosting only one proton, it is called hydrogen. Okay, if it is having the two proton, it is called helium. So this is called atomic number. So atomic number means it is a visual representation through which we come to know about the very nature of the element. Okay, why it is called element? Because it is elementary, it is fundamental, it is making up the universe, it is making up the everything. So that is why it is called element, because the water we drink is composed of H2O, hydrogen and oxygen. So whatever we are dealing with, whatever the air we breathe consists of nitrogen, oxygen, carbon dioxide. The water we drink is composed of H2O. The food we eat is made up of carbohydrate, proteins and vitamins. And whatever we are dealing with is made up of atom. So that is why each atom is represented by its atomic number. So the atomic number is nothing but the total number of protons present in the nucleus. So wow, it is a natural rule that the total number of protons are equivalent to the total number of electrons on the outside. Okay, out of nucleus, the electrons are present. The same number of equal number of electrons will be present in the orbit. Okay, so a proton is representing the element. For example, as I said, if it is hosting only one proton, it is called hydrogen. If it is holding the two proton in the nucleus, it is called helium, then so on. So far nearly you might be knowing the uranium-92. Okay, uranium-92 means the uranium is hosting the 92 protons inside the nucleus, inside the uranium nucleus. We can say, if anybody say, if it is hydrogen, compulsively it will be hosting only one proton in the nucleus and one electron in the orbit. Okay, and if it is hydrogen, then it will be having the one proton. If it is one proton, definitely it will be the hydrogen. Okay, right. So this is how the nature has made it. Okay, so recently, I mean, most recently, the scientific community has unexplored and uncovered these very magical things that is present in and around us. Okay, so that is what we are very blessed to have seen all these things. Even if we have born some 200, 300 years ago, it is very difficult for to decipher this materialistic world. Okay, so we might be simply dodging, we might be simply thinking something very different. Okay, nowadays the science has advanced. Okay, the technology has advanced, and we are living in this scientific era and a technological era. We come to know the reasons for everything in and around us, and through which we are advancing our life, we are making our life easier. Okay, right. So with this, we will be having the break for a short while, and after that, we will be migrating to the next part of the atom. It's a very atomic break now. Okay, so we have in the scientific community have the I mean, they have broken the atom. So we are dealing with the atom in the class right now, and we have the break, and the two in the atomic size. So it is an atomic break, right?